Good evening, everyone. I see that you've been probably going through this the entire day, so I won't take too long. My goal here would be to leave you with some high-level perspective on some of the challenges, security challenges that enterprises may have to consider as they are making that cloud journey. So one of the things that I was actually, thinking about before I kind of, started preparing the presentation together was why enterprises are actually making such a move. But before I go there, let me just give you, I think Sridevi gave me a very kind introduction, but just to give you a flavor of what I have been doing for the last 2 decades in the industry of IT was I joined IT during client-server era, where my first company was Wipro. And I did multi-protocol gateways, terminal access servers. That was my first job, very much into networking. And then I decided to try servers, because that time servers were actually the key thing that was happening. And I joined Sun, where they were doing Spark servers, and I did network file systems. Those of you who still remember manually mounting file systems, I did the auto mounter for Solaris. And then I said, let me join the networking revolution. At that time, Cisco was the one leading the way. So I decided to join networking, and I happened to see networking from all 3 dimensions: service provider, enterprise, and now data center. And I'm so excited to be in the middle of data center transformation at this time. And my topic is absolutely in this area where I'm currently leading the team at Cisco. So hopefully, at the end of my presentation, I won't leave you in a cloud like this. So you will be safe with me. I'm sure during the day, everybody is talking about cloud. I've listened to Dan Green, I've seen Rajiv Ramaswamy, I've seen Jay Parekh. Pretty much everybody, the trend at IT is cloud transformation. But I kind of took the liberty to put this picture together to say that the traditional IT is going away. And you must be wondering why that is the case. Almost every single enterprise right now, well-tested business models are getting challenged. I'll give you an example of Airbnb. I would have never thought that hospitality industry is ripe for innovation. Very, very similar to how Steve Jobs thought phone can be reinvented with iPhone. And that did happen. Airbnb took everybody by a surprise, but then it's not about the business model that got impacted, but the way the business model got implemented was technology. Technology was the platform with which Airbnb completely took hospitality industry by a surprise. And at a time where IT used to be back-end productivity thing, it used to be run by somebody who used to bring efficiency to the organization. But now it is becoming strategic. Now there is a board-level conversation about technology helping business strategy. How you're going to transform the business model with technology. And CIOs are absolutely plotting their journey for every enterprise, I'm sure, on how to make that cloud transformation and stay ahead of their business models. So they've got 3 roads to take. Every enterprise has to decide. Obviously, it's clear that they have to do cloud, but there are some companies who decide to go private. They still do not believe that they can take all the workloads to public cloud. And some who decide to go completely public. Some maybe somewhere in the middle because they've got a lot of assets already in their data center. They would like to maximize them before they move on to public cloud. While the opinions may differ, but everybody has made transformation to cloud. And these numbers will speak for themselves. Amazon started this journey way back early 2000s, but they launched the product in 2006. Just 10 years later, their business is almost close to $6 billion. And as you can see, by 2020, the numbers are really completely ramping up. But if you look at the right side, that is still 15% of IT spend. So as you can imagine, the business is still so big that the public cloud, while we talk about it so much, it's only 15% at this time. And who are these enterprises? I mean, you can look at this chart here. I try to kind of, take some examples. I tried to pick one from each sector. You could see transportation there. You would see retail here. You would see, social coding sites. And you would see hospitality industry. And you will see music industry, Spotify. And you will also see an insurance industry, A&G. I mean, you would think like, they have taken a chance to go public cloud as well. Department of Defense also decided to go public cloud. So almost every single sector has tried to go completely make the move to public cloud. Some of them are on Google, some of them are on Amazon, some of them are on IBM, but they've gone public cloud. Now, what's making these enterprises go to public cloud? The reasons are very simple. Obviously, public cloud is the most cost-effective solution. They consolidated the assets, infrastructure, they did software-defined everything, and they give you business insights. And I was just talking to somebody just before the session, the data is the new oil, and best data these days is coming from public cloud because they have advanced the technology so much that machine learning and big data is giving insights to some of the businesses. Now they can go re-implement the business strategy completely. And that's how a bunch of companies, like Airbnb was one example I gave you, and I'll give you many more as I go through the session, that insights from the data is what's making them make efficient decisions moving forward. Speed. There was a time where people used to turn on a new application in a data center. It used to take months, quarters. Now it takes probably hours and sometimes minutes. You probably would be wondering how you're able to get to your mobile-first, cloud-first data economy era. It's all applications. Everything is run by applications, and applications have to be turned on globally, and they will never go down. And that's only possible because of the cloud. And the third is elasticity. You don't have to invest so much money into data center. You can just go there and do pay-per-use. So it gives you scale up, and it gives you scale down, and you just manage your IT resources very effectively. Now, there are many other reasons, but there are the three reasons why enterprises move to cloud. Now, as I told you, only 15% has moved to enterprise cloud. Why only 15% of the dollars are still being spent here? What's happening to the rest of the industry? Let's look at what are the major cloud providers that we have today. We've got these 5 of them. This is getting very crowded. If I just plot everything, probably this chart will not be enough. But Amazon started in the early 2000s. Google followed the suit. Now Microsoft is making waves through Azure. IBM already started their cloud journey. Oracle has announced that they will do cloud. And then Rackspace has been doing cloud hosting for a decade so far. But the CIOs are significantly still concerned about a widespread adoption. And we did a survey, and we wanted to kind of look at what their concerns are. Survey after survey, I mean, obviously, this is one survey that I picked up. Security is being always cited as the reason why they don't go to public cloud. Everybody is worried about their data. Anytime the data goes outside of their perimeter, they are concerned. Now, is this the only reason why public clouds are not getting adapted? Maybe, maybe not, but today we are going to focus on this topic of security. And now, a lot of people said security is like a fear. You can always kind of, some companies who do security, they always want to make you feel insecure so they can sell their products, right? Some people want you to not move to public cloud, and they may want you to feel insecure. But security is never something that you will be 100% confident on. You can never be confident. But let's kind of at least look at the data. Let's not kind of let our perceptions come in the way of this journey. Last year alone, $500 billion were spent just dealing with data breaches. Just dealing with data breaches. Security is much bigger than data. But data itself, as you can see here, almost every, your credit cards, I'm sure, there are, every single aspect of your data is vulnerable when you are going and leaving that in a perimeter that you don't control. Now, when we look at this, we also want to look at the overall security framework for the enterprises. Cloud Security Alliance has started this tracking various security threats, and they're ranked according to the perception, but also data. And they are treacherous 12. And they used to be notorious 9. So you can imagine that only 3 more threats got added. And the ranking for each one of these threats has been changing from year to year. Security is a constantly changing landscape. And one other thing that's also happening while this technology is becoming more and more sophisticated, attackers are becoming more and more sophisticated. You try to close the loop, they are opening up another door. So this landscape is not constant, and that chart shows you that. Now, as I told you, the data being a big aspect of this security threat, we wanted to also show you on who owns security before we kind of go start solving them. If you think about private cloud, if you own everything, all the way from facility to the network, to the compute, to the storage, and the data and the application, you own security. You have the complete ownership, and that's what most of the enterprises have today. But once you go to public cloud, there are 3 delivery mechanisms. Either you are using just the infrastructure as a service, software as a service, or you are probably using platform as a service. In whichever way you go, security ownership is different. So let's take a simple example of software as a service. If you're using WebEx, this is a Cisco SaaS offering. If you're using a SharePoint from Microsoft, if you're using a snapshot from Google, any application you take, if they are offered by the cloud provider, they own the security. Now you own the data, but they own the security for it. Probably the rightmost one is the most easy one to live on because you don't have to worry about it. You just have to trust them that they are taking care of it. Once you come to a platform, you are writing the application and you own the data. That means you own the security of that. If you go to infrastructure, all they're giving you is just the facility and the equipment and probably everything that comes with the data center, but you own everything above that. So the security is a lot bigger task if you are on the IaaS, and Amazon is probably the biggest in the IaaS offerings. And every single stack here, I put data. There is a reason for that. As I just showed you, $500 billion are getting lost just in the data breaches. So I want to give you a life cycle of a data if you are going to a public cloud. Anytime you think about data, it starts from your end device, right? Most of the enterprises are getting digitized. Everybody has a smartphone, they have a laptop, they work from home, they work from office, but they can be anywhere. They've got a device, they've got an application, and they're working on a particular enterprise application, or they're taking a cloud service. But that data needs to be secure. But this particular area called endpoint security, whether it is a device or a user, is a well understood. A lot of companies have invested money to make sure you're secure. Now, this is independent of private or public, because your data needs to be secured whether you're in a private cloud or a public cloud. But once you go to the public cloud, now you're going to internet. You're reaching the cloud provider over internet, and we call that data in transit. There are many people out there who are snooping on internet. I'm sure internet is for everyone. It's flat. People are snooping over you. When they are snooping over you, you have to protect your data as it is transiting from here to cloud. And there are many technologies here. People have done a lot of authentication and encryption technologies to ensure data is secure from the enterprise border before they go to the cloud. While the data inside the tunnel may be insecure still because it's still clear text, but it is encrypted and it is authenticated, and there is very little chance that somebody can eavesdrop into it. So we can assume that this is taken care of. Now, once you go to data center, immediately the cloud provider is operating on this data that you have transmitted over that, and they are running an application. Now the data is in a clear text. And it's in the processor memory because the application has to deal with it, and somebody always can snoop on the data while it's in use. We call it data in use. If any third-party application, think about multi-tenancy. You are already getting multiple customers hosted in the same cloud. Any other rogue application can get hold of the data. I'll give you an example. Heartbleed. This was a vulnerability that was there, which was recent as probably last year. And when you have a vulnerability of a Heartbleed, which is an OpenSSL bug, you can track data in the memory, and you can take that data with you. So if you host an application in that environment, you can take the data with you, and you can transport it out of the cloud. And that's your data breach. So data in use is probably the most probably nobody would talk about this because cloud providers will never tell you about this, but also this is an area where this is mostly overlooked from the industry. And then data at rest, once you're done with the data, you want to store it. You want to put it in a file system, you are putting it in a database, and most of the time you're encrypted, probably you're replicating it in multiple data centers, so you're never going to lose it. So the data in transit, data at rest are well understood, well handled, but data in use is still an exploratory area, and a lot of hackers are looking at this. So when you're in the middle of this kind of a security journey, how do you achieve security? The first thing you need is visibility. You need to make sure every workload that you're trying to consume from the cloud, you're able to have a visibility, almost granular visibility into the infrastructure, whether it is network, compute, or storage, and the data that you're putting on it. And then once you have that, you need to have policies and governance on that. How do you make sure you're trying to put operational policies to protect yourself? Then you can never achieve this with a human, because you know that human is the weakest link in the security arena. You don't want humans involved in the security. You want automation. And as you can see, public cloud probably has gotten very, very far on this journey of automation. And also there is one contrary opinion I've heard from Dan Green today, that public cloud is more secure than private cloud. And I actually believe in that, because the security being a niche skill set, there are not that many engineers who know how to deal with security. And the more and more you think about security, you need engineers who know how to handle that. And Google gets attacked almost every day, right? I'm sure the data that they have, everybody wants it. And in that, they have created 600 engineers to handle those threats. And if they're hosting that cloud, you can probably trust that they're probably up to date on how to handle security threats. But that's one opinion, right? The rest of the industry still has to see it for themselves. So in order for enterprises to really kind of get to effective security, these are the 3 key pillars. And security is a continuum. It's not a one-time operation. It's a 24/7 operation. So you're constantly mining the data to get correlation, and then you're also trying to figure out anomalies, and then try to put policies so you can detect a hacker before they even make it too deep into the network or too deep into your infrastructure. And there's one other data point that I want to highlight here. The traffic within data center is 75%. And traffic from data center to the user is only 10%. And the data that actually comes from the device is very little. So the data center itself needs to be very well protected. And I talk about cloud, cloud is all about data center. So how are people doing it today? People already have some solutions. We talked about those 3 pillars: the visibility, policy, and automation. And the building block for doing all these 3 things together, it's called Cloud Access Security Broker. What people do is, like companies like Sky High, people like Netscope, all of them have put together visibility tools, compliance tools, governance tools, and malware tools in a block. They will integrate with your IT systems. They will also integrate with the cloud provider that you are hosting your application on, and they will do the governance and give you visibility. So at least you know what's going on. They can't protect the data for you because that's still in the cloud, but they will at least let you know if you are somebody from an enterprise is attacking the cloud, they will block it. If somebody from the cloud is attacking your enterprise network, they will block it. They're able to give you, if somebody is going and not managing their workload with a policy, so you're downloading a document or you're uploading a document which is confidential, like Cisco has a box in the cloud. And we actually put Sky High based solution in the middle. So if anybody does that, we will remove the document from the box. While box is an offering from the cloud, Cisco is an enterprise. We won't want our documents to go on a public cloud, but we want to make sure those which are not confidential, you can always take to the cloud. That is possible, and most of the enterprises are already doing this. Apart from this, Cisco has made a lot of investments in the last 2 years to really kind of play into security. And there are 2 companies here which we talk about. OpenDNS, which is an acquisition that company made like just 6 months ago. This is about before you even go to a host or a website. If we believe that that's an infected site, we will not let you go there. If it is a content that you're trying to kind of go and that is malware, we won't let you go there. So we apply policy at the domain name query time itself. So you're able to kind of really protect yourself from any security threats before they even come to you. Let's assume that that path didn't work. Then you got an endpoint protection with anti-malware, AMP. This one, once the content is there, we will be able to do a signature check, and if there is any threat that that content provides, we will block that host. That host cannot talk to anybody. That particular end device cannot talk to anybody. At least you quarantine that. So you can't avoid the threat, but you kind of limit the threat. Then there's a firewall. At least, if you believe that endpoint could not detect any signature, you're still trying to figure out how to go to cloud, we put firewall policies. And we've got an acquisition that we made called SourceFire, which gave us a wonderful technology for dynamically looking at the data, understanding the anomalies, and putting firewall policies that can protect you from getting hacked by anybody coming from outside. And then LANCOPE is all about visibility. We've got a solution where we want to make sure that you know exactly what's happening between you, your enterprise, and the cloud. So these 4 solutions already Cisco has provided, and they are offered with that Cloud Access Security Broker for any enterprise if they want to make a journey to the public cloud. While we were trying to solve the problems of yesterday, the new problems are coming our way. The entire landscape is changing again. We are talking about software-defined network. Now we are talking about software-defined storage. Data is getting virtualized. Network is already virtualized. And then applications want to be, they want to kind of go and scale their applications as more and more customers are seeing cloud first, mobile first. Mobile first means there are a lot more consumers of that application. And you want to scale the application, and you want the applications to be available all the time, and you also want to provide speed for that application. So they started this trend about microservices. It's about dividing the application and trying to do the services independently. So they can be upgraded independently, they can be triaged independently, and they can be given to the customer at a different pace. And to implement that, we need a different virtualization technology on the containers. So we've always done VMs. Everybody has done VMs. That was primarily to drive virtualization on the hardware. You wanted the server to be utilized. We gave 7 times the benefit after VMs. But now people want more out of a server. So they're trying to manage virtualization at a software layer. Take an operating system and try to use that across container workloads so they become lightweight, they are portable, and they are giving you modularity for microservices. So containers are becoming the new virtualization technology, and microservices are the mechanism to implement new way of writing applications, which we call it cloud native. So let's kind of take one look at that. What does that mean to us as a security concerns? How does this help or does not help? In the past, almost every service of an application was implemented in a single application block. It was a monolith. Everything is kind of thinking about, people are trying to virtualize everything, and now application is looking like monolith. Even though it had 3 tiers, there was a web tier, there is an app tier, and there's a database tier, but all 3 tiers are very well managed as a single application. Let's take an example of Uber. Uber is trying to kind of give you transportation, and remember I told you about business model getting impacted. And they completely changed the way transportation is done. And a driver wants to track where the passengers are. Passengers want to track where the drivers are. Why do you want these services to be together? Let's put them separate. They are 2 microservices. Billing. When you're managing a billing, you may be doing PayPal, you may be doing Apple Pay, you may be doing something else. Why do you want to keep that in the whole application? Run billing separately. You want feedback on the driver, passenger wants to provide. There is a feedback on the driver that passenger can be provided or driver can provide on the passenger. Both can be done as a microservice. Now, every microservice now has an end-to-end flow. They don't depend on each other. As soon as they depend on each other, there will be conflict. And you don't want those conflicts to occur. And you want them to scale independently. That means you are scaling each one of these microservices in a way that more drivers come on, it can scale independently. More passengers come on, that will scale independently. And billing, you can add a third-party integration without impacting the rest of the application. You want to update the passenger side every day, you can do that. So upgradability, modularity, and speed and scale, all of them have come. Now, so what's the concern? Here is the concern. You had one entry point into the application in the past. Now think about how many entry points are there into the application. You have created higher and bigger surface area. The more surface area you create, hackers love that. Because you probably cannot close every entry point. Because as soon as you close one door, they will come at the other door. And now, as I told you, public cloud is all about hyperscale. They may not be running in the same data center. You may be running one application in 4 data centers as well. So the surface area of this basically gives you higher vulnerability for security. Containers, there are a lot of technologies, but Docker is gaining a lot of adoption. And this technology right now is used almost in every public cloud. And a lot of people are also using it in the private cloud as well. And we want to look at containers. While they are very good for lightweight, they're portable, they're also giving you this feeling of using the server much more effectively. It also brings some threats. It is kind of running on the same operating system. The operating system is shared. If there is a vulnerability on the operating system, container workloads will interfere with each other. They can interfere with each other by either kind of impacting the environment, runtime environment, or they can share the data from another container. So one application is looking at another application data, or one application is impacting the host itself, where you're running other container workload. And if it goes down, the other application is impacted. We don't want all of that. And what people have done is, all the industry vendors, they have figured out, let's kind of bring security into container work environment. And they have done a lot in this area. The Linux operating system has a lot of capabilities to protect yourself. In the name of either namespaces, C groups, every technology that is here, developer needs to understand and use it. It's quite complex. Even though the technology is there for protecting your host, the people have to be trained to write an application using these technologies. To an extent where I think probably Rajiv Ramaswamy left, and he actually mentioned you can run this in a VM. Now imagine, I can do that. You can take a container, run it in a VM. Why are we doing containers in the first place? You want to really give portability, you want to run at a lightweight, and you will lose all of that. While you get security, but you lose these benefits of container and microservices. So while an opinion exists, I think industry is still looking for answers. Now, I also want to kind of give you a pillars for what we need to do to protect ourselves. For in this container world, in this microservices world, how do you get more security? You want the host, whatever host you're working on, operating system is, some people use any kind of Linux distribution. They may use any kind of container, any kind of open source tools. How do you make sure they don't have any security vulnerabilities? Do a compliance check. Make sure that wherever you're hosting your workload, they do not have a loophole. Then you also want to make sure the network also does not have any loophole as you're doing a multi-tenancy. While container has really become famous, they are still single tenant. They're not really multi-tenant. So the networking technology is not evolved in order to give you a policy for supporting container workloads. And you also want to make sure there is security where one container workload does not interfere with another container workload. As long as you take care of these 5 pillars, we would be able to achieve effective security to run microservices-based applications in your data center. What is Cisco doing in this area? So you've heard about open source everywhere. I'm sure since morning you've been talking about there are solutions that are available in the market. But then somebody has to put them all together and give that as a stack and then supportable like a way Red Hat is doing for Linux. So Cisco is putting a stack together for hosting microservices through Mantle. Mantle is about putting container infrastructure, runtime environment, various tools that you need to host a microservices architecture. That's called Mantle. Now, we also believe we need to have a policy to support that. So Contiv is an open source sponsored, Cisco sponsored this project, and we are still inviting ideas into this, and it does policy application for network, compute, and storage, so they can be used without any human intervention, and you can automate on top of that. So between Mantle and Contiv, Cisco is trying to kind of encourage innovation in this area where enterprises can become more secure as they are going into this cloud transformation.